Exercise 315 says consider the density curve shown in figure 313, which represents the distribution of diameters measured 4.5 feet above the ground in a population of 30-year-old Douglas fir trees. Areas under the curve are shown in the figure. What percentage of the trees have diameters between 4 inches and 10 inches? So what percent is between 4 inches and 10 inches? Okay, so the density curve is very similar to a probability frequency distribution, except rather than in table form, it's given in a graph. And here they actually give us the numbers. So we can almost think of this as a table where it's 0 to 2, 2 to 4, and the corresponding percentage or whatnot is, as you can imagine, just like this, 4 to 6, so on and so forth. Okay? But most often when you see a density curve, it's just a curve without any actual numbers underneath. But in this case, we treat it this way with numbers, and we can also think of it this way. Sometimes we have to use a table in the back of the book later on to find out. But anyway, here we're trying to find the probability that it's between 4 and 10 inches. So that is going to be between 4 and 10 inches, so from there to there, so that's going to be 0.33 plus 0.25 plus 0.12. So let me add those up. And that adds up to 0.7. So 0.70. B asks, what is less than 4 inches? So that's going to be from here to here. So x is less than or equal to 4 inches. The diameter of the tree is being less than 4 inches, so that's going to be those that are 2 inches or less. There's only 3% of trees fall in that category, and the 20% that are between 2 and 4 inches. So that's going to be 0.23. And finally, it asks, what is the probability that it's more than 6 inches? So let me just get rid of this line. So we're interested in here and up. Okay, and so we can find x greater than or equal to 6. That corresponds to 0.25. 6 to 8 plus 8 to 12, 0.12 plus 0.07. And if we add that up, you get 0.44. If you want to add up different numbers, you can also do 1 minus the probability that x is less than or equal to 6. Alright, I'm doing the exact same problem, except now I'm going to find out this side, and because we know all density curves, the total area underneath the curve is equals to 1, we can do 1 minus the area that's on this side. So that's going to be 1 minus 0.33 plus 0.20 plus 0.03. And that's equal to 1 minus, and this, if you add that up, it adds up to 0.56, and you get 0.44. So you can solve this in multiple different ways, and in both cases, our answer is exactly the same, as it should be.